So this is the instruction clip of exercise 3b. We have this function here, given as this function, the logarithm of 2x plus 1 to the base 3. And we're asked to find the formula for this function here. So what happens if we take this g of x and we construct it as 3 to the power of f of x? So what happens if we put this here to the power of, in the exponent of 3? What kind of functions do we get then? In order to answer this question, let's quickly revise what this expression here actually means. So the logarithm of 2x plus 1, this is our f of x to the base 3. What is this? You see, this expression says, so if I want to get 2x plus 1 and I want to express it 3 to the power of something, what do I have to put here in order to get this expression? Yeah, so this is the term I want to express as 3 to the power of something, and what is it that I have to put here in the exponent in order to get this? This is the definition of the logarithm. Now if we, so this question mark here is the definition of the logarithm. So now if we now consider this function g of x as 3 to the power of f of x, which is 3 to the power of logarithm of 3 of 2x plus 1. And this here is exactly our question mark. Well, then we have, this is 3 to the power of question mark, and this is just 2x plus 1. Or, in other words, 3 to the power of logarithm of 3 are inverse functions, and this is always just the argument of the logarithm. So for example, 2 to the power of logarithm of 2 of anything x is x, or e to the power of the natural logarithm of x is equal to x. So whenever we take a base a to the power of logarithm of a of anything, let's call it x, then this is just x, because these two operations here, they are inverse in the sense they're not doing anything together. So our answer is g of x is just a very simple linear function. G of x is 2x plus 1.